Well, hello guys, here Mr. G with another video related to vectors and scalar for the grade 10. However, it will help the grade 11s and grade 12. They need the concept and the topic. Now get a book so you can write the notes. There are important notes that you should know and some important details I'm going to speak about here. At the end of this little video, you should know some properties of vectors. A very important one is equality of vectors and negative vector, and then we are going to be able to learn the resultant vector. So saying that, the first thing we are going to learn is about equality of vectors. Now, two vectors are equal if they have the same magnitude and the same direction. So two vectors are equal if they have same magnitude and same direction. Remember, we're talking about equal vectors. All right, for instance, force 1 and force 2, because they have the same magnitude, and that you can see it by the length of the vector, it means that those two vectors are equal in magnitude, and because they are pointing in the same direction, it means that the vector are equal in direction. So these vectors are equal let's write that one, in magnitude and direction. All right, so that is the first important note. If they have the same magnitude but different direction, they are just equal in magnitude. For example, these two vectors here has equal magnitude. You can see the magnitude by the length of the vector. However, they have a different direction, so they are not fully equal vectors. They just equal in magnitude. Or you can have two vectors that have the same direction, but they are different in magnitude. Here, for example, these two vectors now have only the same direction, but they are different in magnitude. So two vectors are equal when they have the same magnitude and the same direction. This is very important definition because we are going to be using that concept. Now, another definition we're going to do, and to me is one of the most important, and the learners attempt to make mistakes here, is what is a negative vector? Now, a negative vector is a vector that has the opposite direction of the reference positive direction. Now, reference positive direction is a direction that is being taken by convention. So it means that this direction here was taken by the person that is studying this problem. So for this specific person, who is anyone, could be the teacher, the learner, or whatever, say the right, for instance, is a positive direction. So all the vectors that are pointing to the right are going to be positive vectors. Vectors that point to the right are positive. Vectors that pointing to the right are positive. Remember, this is by convention. So in this case, right was taken as positive, and therefore any vector that is pointing to the left are going to be negative. So vectors that is pointing to the left are negative. Why is that? Because of the direction. It was taking positive direction to the right, for instance. However, if somebody say, sorry, I'm pressing the game in a different place. Here we are. So let's say, for instance, in this other problem, down is positive. So it means that all the vectors that are pointing down are positive. All vectors pointing down are positive. For instance, let's say F1 here. This one is a positive vector. F1 is positive because it is pointing, as you can see here, in the direction that we took as positive. And in this question, down was taken as positive. And then all the vectors that are pointing up are going to be negative. For example, let's use another color here so you can see it nice. Let's use, for instance, blue. So any vector that is pointing up, this is F2, is going to be negative because the direction is in the opposite direction to the one we select as positive. This is a very important concept. Let's go to the next property we have to speak here. Now, it is very simple. It is when we multiply vectors by scalars. For instance, let's say we have a force F, but we are going to multiply by the scalar 2. All we have to do is to make the length of that vector 2 times as big as force 1. There we go. So you can see there is 2 times as big. It's like doubling that specific vector, but the direction it keeps constant. However, if you multiply by a negative scalar as it is here, then it is going to be double but pointing in the different direction. I think this concept here is quite simple. There is not much to speak about that. You can triple, you can multiply by 4 or etc. Now, this is a very important definition because you are going to be asked this definition all the time. Resultant vector is a single vector having the same effect as 2 or more vectors together. In other words, we can say that is the sum of all vectors. So to calculate the resultant vector, which we are going to use the symbol FR, also not important. You can use FR or you can use FNet, it doesn't matter. In this case it's for F because we're working with F, but remember, force is not the only vector quantity. So you can see that the F total, instead of total, we're going to write FR as it is here, and it's going to be the vector addition. Remember, these are vectors, plus F2, these are vector addition, let's keep the symbol there, plus any other vector. This is how to calculate the resultant vector. Now, to do this one, we need to have in mind the direction. So the direction, guys, is a very important thing here. You cannot forget. We have to keep the direction, and remember, when we spoke about the negative vector, we need to be careful what direction is positive and which direction is negative. So to finish here, we are going to see this example. I added the following vectors: F1 to the right, F2 to the right, and F3 to the left. So we have vectors pointing to the right and we have vectors pointing to the left, and we're going to add this one algebraically. Later on, we're going to learn about graphically. So when you add in vectors, the first thing you must do, so let's write, for instance, step 1, and then I'm not going to write all steps, but the step 1 is to select direction. And remember, you are going to select the direction, at least your teacher tells you which direction you are going to do that. So in this case, let's say right is positive, and that is a very important thing. You must write it, you must show it's nothing difficult of that. So if we do that, then let's go to step 2, which is the data. So what we have that F1 is equal in magnitude to 3 Newton. To the right, we said right is positive, so this 3 is going to be a positive number. F2 is equal to 1 Newton, also to the right. I am going to write here positive. And then F3 is going to be equal to 0.5 Newton to the left. If right is positive, left is negative, therefore is a negative vector. And step 3, guys, is just adding the vectors here. So we're looking for net or resultant. Let's write FR as we did previously there. It's equal to F1 plus F2 plus F3. You write everything by adding with the symbol. And now when we substitute the either positive or negative. So it's 3 plus 1 plus minus 0.5. It's quite simple, guys. So this one is just adding. So you get that the resultant force is equal to 3.5 Newton. Now here is only the magnitude. We have to give a direction. Remember, vectors need direction. You can see that the answer is a positive number, and we say positive is to the right. So it means that the resultant force is also to the Right, so this is the final answer for this vector addition. Here is very simple. It's the first example we are going to do, and then guys, to finish, we are going to the very last concept of this video, and as well the end of the video. As I said, the equilibrant is the vector which have the same magnitude but opposite direction as the resultant. So if the resultant is this number, the equilibrant, sorry, will have the same length, but it will be straight in the opposite direction. This is the last definition. It's quite simple. You have to learn. It's not much here. And this is the end of the second lesson related to vectors and scalar. I hope it helped. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.